lottery program. So the lottery program will generate 2 digits, random digits, and then we'll prompt the user or the player to enter 2 digits. If they match in the same order, the player wins 5,000. Match but different order, 3,000. And if just one of the digits match, 1,000. So we've got our class, and we know we've got to do this comparison. And this comparison between the randomly chosen lottery numbers, digits, and the players is a single concept. And so it'd be like, let's write a method for it. So typically we would call this a lottery ticket, right? So what if we say this is public static int check ticket, and we need 2 characters, so the hidden ones, and we need 2 characters for the player. Okay, so the hidden ones and the players ones. And I can imagine some different names there. Maybe instead of guess 1, guess 2, player 1 guess, or player guess 1, player guess 2, something. But these seem reasonable for now, and we could refactor them later if we need to. As far as the int returning, I'm anticipating just return the amount they won. And so based on that, we can give them some other feedback. So this is just check the ticket, return an amount, and then we'll call this eventually from main. But let's focus on this. So we've got our different cases, or maybe we should assume we have this. Let's just stub this for now. So we'll just return -1. So I'm doing that so at least it compiles, since we have a return data type, and returning -1 in all cases, basically it'll make it compile. And we can just summarize this briefly. So we can just say compares the hidden with the guess and returns the amount 1. Okay. And let's leave that for now, and just leave it stubbed right there. And so typically it's a good idea to know how we're going to be comparing this. And so we need to be able to compare all these situations and then the none. So there's kind of 4 situations we need to figure out here. And we might as well write a testing routine for it. Public static void test check ticket. And we need to be able to say each of these cases. So how about if I just copy these down here and we make up some test cases. So we know we're going to want to run check ticket and 2 digits, same order. And so what if I say 0, 5, and then it should be 0 for guess 1 and 5, and then the value returned should be 5,000. So how about if we just do that? System out print line, and just say 5,000. And we know the context is that we're comparing the result to 5,000. And so got to make sure I got enough parentheses here. And what's the compiler complaining about? Okay. What it's saying is that we process left to right. So this will be, concatenation will be applied first, so this string in the result before that. In other words, I need to have parentheses here. So we try to concatenate, but we can't concatenate until this is done. And so we do the comparison and we'll concatenate true or false. So if it says 5,000 true, we know our test was successful. Okay, so we can do that. And let's just at least create a case for each of these. Let's try some different digits so we know it works. Okay, so a $3,000 case is same digits, different order. A $1,000 case is one of the digits matches. So how about 1, 5, and then 2, 1. Actually, the 5 was fine, right? Here, I'll just do 2, 1, just so we're using different digits, mixing up the comparisons. So basically, I'm testing to see if this matches, and it should be a $1,000 case. And then here, we've got no digits match. And so it should equal 0. Okay, so we should see true printed off 4 times, basically for each of those cases. If it's false, then we know the whichever case did not work. Okay, so we've got at least some test cases. This isn't proving it, but it's given us some assurance that it's working. So we've taken one idea of one part of our program, we're going to need to compare it, and stubbed it, and now a test. And we can just set up call our test check ticket, and it should fail, right? Because it'll return 1 every time. And so let's just run this. Okay, false, false, false. So failed. So we've got a failing test case, which is great. This is test case fail. Now we've got to write our code to complete these. So this is referred to as test-driven development, what we're practicing now. And for this particular situation, it can work fine. So let's compare these. So basically, we're starting to use the logic of this chapter. So if hidden 1 equals guess 1, so we're doing the comparison that they match in order. And hidden 2 compares with guess 2, then return 5,000. So doing this, do they match in order? That's the way we get 5,000. And we really ought to put our algorithm here, right? So let's, or, statement about how we're doing this. If the characters, and I'll say characters because we're using char here, characters match in order, the result is 5,000. If the characters match in a different order, the result is 3,000. If one of the 2 characters match, the result is 1,000. Otherwise, 0 is returned. Okay, so our problem. And we might as well fill out a little bit more of this. Hidden 1 is first character digit chosen by the game. Second character digit chosen by the game. Guess first and I chose the data type char here, so we'll actually use characters. You could just use an int or even a byte as well, but I want to use characters, so either one will work. Okay, return the appropriate amount 1 based on comparison. Okay, hopefully that's clear since we gave the algorithm. So we've got this case. Now is it appropriate to do another if or an else statement here? And let's think through this. Could I check out of order and return 3,000? Yeah. So since I'm returning 5,000, if this situation happens, I'm done, right? This method is done. There's no need to worry about what happens. If this doesn't, then I could do another if statement. So maybe we check this situation. And then maybe we have another if statement to check this situation. Or we can return 0. However, in this particular situation, while it could be done with if statements, I really like if else, because we know we want only one and only one of these options returned. We don't want a case where 5,000 and 0 or 1,000 and 3,000. We don't want that. And so I'd like the code to be pretty clear that it's one and only one of these options. So I'm going to do an else. Else if, and then this is our second case. Else if, so same digits, different order. So hidden 1 is guess 2, and hidden 2 is guess 1. Okay, then return 3,000. Else if, and now we need if one of the values matches, right? If one of the values. So both of these are if both values match. So we know it can't be both if we get to this. And so one of the values. So we need to check the different possibilities. So if hidden 1, guess 1, or hidden 1, guess 2, or hidden 2, guess 1, or hidden 2, guess 2. Then return 1,000. So if any of those match, and since we've already checked both possibilities of both matching, then there isn't the possibility that both still match here. So we can go through these different cases. Note, we could not put this first because then all these cases match at least one, right? So we've got to check this condition after eliminating these other two possibilities. Okay, now, so we know that no one matches, we can simply say else, return 0, and we've covered all other possibilities. And so all possible cases are covered. And let's run our code and just test these cases and see what happens. True in all cases. Cool. So we've written a section of our program, a key method of our program. And now let's write the main. We can comment this out, lottery, and then we want to, about random number generator, random alt enter. Yes, I do want it included. It just imported it for me with those keystrokes. System or random. I don't want a seed. I could put a seed there so it's repeatable, but I don't want a seed. And so let's do this. And I want a hidden value. And so how can I randomly choose a hidden value using the random number generator? The random number generator returns an int. And so let me show you a technique for converting it. So we know, and our problem will be choose a number from 0 to 9. I think that was in here somewhere, but choose a number from 0 to 9. Technically, we don't need that limit, but it'll be, the more choices there are, the more difficult it is to guess. So if I want a number from 0 to 9, I can say 10, right? Because this returns 0 to 9. But now I need it as a character. And so what I'm going to do is add it to whatever is the ASCII or Unicode value of 0. Because the character digits are sequential in the ASCII and the Unicode tables, starting with whatever the value is. So when 0 is returned, I add 0 to this, and I get the 0 character. And so what I want to do is typecast this to a char. So after I add a character, add a number to it, and recall that this isn't concatenation. An int plus a character is an int. Okay, it's not a string. It's not concatenation here. And I'll get the character, or I'll get the Unicode value for the character 0 if I add 0 to it. If the randomly returned number is 1, then I'll add 1 to character 0, which will give me character 1. I'm typecasting it to a char, and we'll see that. So we can say hidden 2, and actually it's almost identical to this line. So let's do this. And you know what? Sometimes it can be useful to just bring in a Java visualizer or something like that, another program, and let's just see if I've got this little bit working. So let's just put this code in here and see, and I'll have to import. So import Java util random. And now let's just run this and see what happens. See if I've got this code right. 6, 1. Okay, let's try it again. So it's coming in as digits, and it seems to be producing the characters that I want. Okay, so I'm okay with that, but we can just isolate some sections of code and test it if we want. We could just run this program as well and see what happens, but then we'd have to print it out, or we could step through, use the debugger. So let's do that and use the debugger, and notice let's step. Okay, it got 6, or 54 is the ASCII or Unicode value, and then which maps to character 6. And 2 is 50. Okay, so that's matching up. So it's just showing Unicode 50 maps to character 2. Okay, so we can verify what we're doing either of those ways. And so we've got our hidden code. And so now we've got to get the user input. So we can use scanner. How about just print, enter your 2-digit lottery guess. Okay, and by doing a print instead of print line, the cursor will be left after the colon for the user to enter. But we don't have this enter. And let's see, cannot resolve it. Suggested Alt-Enter. Did it put it? It didn't. Let's just do it manually. Okay, sometimes I get the keystrokes wrong. Okay, enter your lottery guess. And so we're going to have 2 digits typed in. So let's just get those. We can just use next to read those in. String guess is input next. We can check that there's 2 characters. And if they didn't enter 2, give them an error message. So if guess.length is not equal to 2, so if they entered 1, 3, 4, we're just going to throw it out and let them know. Okay. And let's simply return. So this is a way we can leave the main method right here. Since the main method is void, we don't return a value, but we just say leave. So an error message, and we're out of here, program done. So if we get past here, we know guess has 2 characters. So let's get those individual characters. So we can say, guess 1 is guess.char at 0. And so we're directly indexing into this string to get the 0th character and then the first character. Okay, so we've got our 2 characters, and then we can call our method. And so we can say check ticket that we created earlier, 2 hidden ones, hidden 1, hidden 2, guess 1, guess 2, and then int amount 1. So amount 1, and then we can just say system out print line you, maybe congratulations. Amount 1. Okay, but saying congratulations, you won 0, that's not a good case, right? We need to handle that. So if amount 1 is 0, then else this. System out print line. Unfortunately, you didn't match any digits. Please buy another ticket. And yeah, okay, you can imagine the wording there. Okay, and so let's see if it works. I can turn this off. We've walked through those. And let's run it and see what happens. Enter your 2-digit guess. What if I said 777? Error. Expected exactly. So I handled this case. Okay, let's run it again. 77. Hey, $1,000. And this is a little bit odd because what was the lottery number? And that actually may be useful to print out, right? Maybe we should print it out. And so check ticket and then system out, print line, winning numbers were, or we called them digits. Digits were, and then we can say plus hidden 1, hidden 2. And if I put parens around here, it would sum the ASCII values. But since this is left to right, this should just concatenate those to the end. So let's run this again. Enter your lottery guess. Let's just try that one again. 87. Okay, we matched 1. Let's try it again. How about 81? 03. You didn't match any digits. Okay, let's try it a few more times. 92. No. Okay, so we wrote our little program. We identified a key part, put that part in a method, tested the method, and then did the input and output and use of the method in main.